Hello everyone, welcome back to the Modelling Novice, and this is episode 7 of my first layout build, Fir Tree Halt, and today I'm doing something a little bit shocking. Right, I'm going to apologise for that dad joke, I am sorry, but I couldn't resist. So how am I switching things up? Well, I've got some of these. This is a seat solenoid point motor. Now, as you can see, this one has already been used. Now, my friend Kevin had initially started to install these onto his layout, but then halfway through decided that he was going to use cobalt motors instead. So, everything that he's got, he's just handed to me in a box, and he's also very kindly 3D printed me a little panel for the switches to go in, and that is going to come in very useful indeed. So that was very kind of him. So at least that kind of stuff's not going to waste. I've never really done soldering in electrics before, barring a couple of little quick bits and pieces. So this is going to be quite a big task for me, and one I'm actually quite scared of. Hopefully the results will speak for themselves. So I think the first job is to get the point motors installed and then work out a plan of action for the wiring.
Now, if we cast our minds back to the second episode in this series, you may recall I pre-drilled holes in the baseboard to accommodate point motors. I was unsure at the time whether I would install any and what type, so I drilled the holes just in case. My first job was to make sure the surface around the holes was nice and flat so the motors could operate with as little resistance as possible. Once that was done, I could start installing the motors. I was given 6 motors in total, 4 had been fitted and 2 are still in the boxes as new. The pre-fitted ones already had the arms cut to length, which made installing them a little tricky, but they were at the right height to reach the tie bars. The new motors will be easier to fit, but will require trimming afterwards. After taking great care to ensure that the arm is located in the tie bar hole, I hold it in place to stop it from coming out, whilst I secure to the baseboard using 9mm self-drilling screws. I could have drilled pilot holes, but I was uncertain of the motor positioning, and this was a much easier way of doing it, as if the motor slipped, it would fall out of the tie bar. I then repeated the process with the other motors. I'm leaving on any wires already soldered for now, as I may be able to keep or reuse some pieces. I still have one point motor uninstalled as of yet, but the reason will be shown soon. For now though, you can't fit motors without something to power them, so I'm also installing a capacitor discharge unit to the underside of the baseboard. Solenoid motors require a short burst of power in order to operate, so fitting one is essential. This unit and all the motors are from Gagemaster, so I am confident that everything will work as intended. I am also installing the auxiliary power feed. These have screw type terminals, so I insert a red and black twin wire to the input of the CDU and fitting the other to a two-piece female section of a plug and socket type connector strip. I will have another red and black wire going from the controller to the male end, allowing easy plugging and unplugging from the controller. With that in place, it's time to cut down the motor arms to length. I started with my rotary cutter, but it was so weak I resorted to a junior hacksaw. With the hardware install now finished, it's time to start the wiring.
Okay, so I've initially gotten started by installing some of the motors. Now, the fifth motor here, I'm going to have to cut a little bit out of the framework here. A bit less than ideal, but that's hindsight for you. You'll also notice that this, I've done that too. This is so I can fit the Gagemaster controller. It also means I get rid of that unreliable power clip because I have been having issues with it. Now, I do need to widen the hole here to get that through and fit there. I've got some more of these connector blocks, which, as you can see here, fit together quite nicely. So they're going to be on the outside because this is going to be a front control system. You can also see as well, I've already installed the capacitor discharge unit, and the next job for me is to get things start wiring up once I have gotten that final motor installed. Now, the biggest thing that is scaring me about this is because I've never really done electronics and wiring before. It's something that I'm not familiar with, and looking at the initial sketches, I wasn't 100% sure on what I needed to do. So what I've done is I've sketched out a rough template of what I need to do, double checked it, and yeah, okay, what I am imagining in my head I need to do is correct. So without further ado, let's get cracking.
So let's take a look at my circuit diagram, starting with my CDU and auxiliary input. My 5 motors at the top and 5 switches are at the bottom. As the motors have capacity for an additional function such as lighting signals that are interlocked with the points, there are 6 terminal points on each motor, 3 primary, 3 auxiliary. I'm not using anything that requires the auxiliary supply, so I'm only focusing on the terminals A, B and C, which are the primary. The first task is to work out the installation of the common wire for which I am using green. This runs from the CDU positive output to the common terminal on the motors and from the switches to the negative terminal. I am using a detachable control panel. The switch wires will be run through the bank of male-female connector strips. The 2 looms are not connected to each other in a single loop, otherwise it would create a short circuit. Next, I figure out the A-side circuits for which I will be using red wire. Each motor A terminal needs to be connected to the A prong on the corresponding switch. I will number the motors and switches to ensure that they match the control panel position. Finally, the B circuits will follow the same pattern as the A circuits, going between the corresponding switches and motors. For this part of the assembly, I will be using white wire, even though they are displayed in yellow on this diagram. Now I have my plan of action, I can get out the soldering iron and get started. I'm going to start with the switch panel first. Some of the switches are already connected, so I only need to bridge any unconnected switches and run the feed to the connector strip. The switches are SPDT momentary switches, single pole double throw, which have a spring return. This means that when you throw the switch on the A side, it completes the circuit between the switch and the motor by sending power to the A terminal of the motor from the CDU. The burst of power then energizes coil A on the motor, pulling the bar across before switch returns to off when released. The burst of power then energizes coil A on the motor, pulling the bar across before the switch returns to off when released. I cut a section of green wire to length, strip the ends and screw one end into the female terminal strip. The wire is passed through the back section of the control panel, which will be assembled and glued together once the wiring is complete. Once this has been fed through, I can solder it onto the end of one of the switches. I cut small pieces and solder the remaining switches commons in series. It doesn't matter which order they are connected to that green wire feed, as long as there is no complete circuit until a switch is thrown in a specific direction. Next up, for the red wires, for circuit A. Each switch is now numbered to match a corresponding motor on the baseboard. I cut a piece of red wire to go directly from switch 1 to the terminal block, before repeating the task with the remaining 4 switches. The A terminals will remain unbridged to ensure individual control of each motor. With the red wires complete for the A circuits, it's time to do the white wires for the B circuits. This job is just a repeat of the A circuits, but soldering onto the B terminals on the switches. With the panel finished and the soldering iron still hot, I turn my attention to the underside of the baseboard. I've already removed any wires I can't use, and I've already made a start on the common feed by using the longest green wire as the main loom to wire into the CDU. It's going to remain loose for now, as I'm going to splice the insulation and solder feeder wires onto the other motors from it. I will then seal each joint with heat shrink for safety and strength. Once all the other common feeds have been attached, I can wire the common feed into the CDU output positive terminal. I also run a wire from the negative terminal to the male connector strip, threading the wire through the hole in the frame in the process. Next job is to run the A and B circuits by running red wires from each motor's A terminal to the corresponding terminal in the connector strip, then running white wires from each of the B terminal to the strip. Again, all wires are being threaded through the frame hole for easy attachment and detachment of the control panel. Once everything was installed, it was on to testing, but things weren't going to plan. There was no movement from the motors despite my wiring being correct. Over to me to explain more. Well, that was quite a ride. So, as it transpires, when I'd initially started trying to test everything, it didn't seem to be working. Now, because obviously I've had other issues with this layout in different places recently, I thought I'm just going to walk away and I'm going to come back to it. At the same time, I was also talking to Steve, the British Railroader, via email. Had a good chat with him over the seat motors, trying to see if I can find out what was going on with it. So I took a multimeter, did all the tests and everything else. I've got continuity everywhere. Everything was plugged in the right places. I've gone over my circuit diagram as well. And I was just completely confused as to what was going on. Bear in mind, at this point, the layout was set up, point motors were in that orientation. However, when I'd moved the layout so that the point motors were like that, and that I could see behind the board so it was upright, when they were like that, I actually started getting some life. I also noticed that a couple of connections were loose or not that clean, so I ended up stripping back a bit more of the wires, making sure that the terminals, the screws in the terminals were actually affixed properly, laid it out flat properly, and then they started to work. I'd also taken one out to test as well, so I was actually getting power, but by the time I'd actually laid everything flat, it was working. A little bit of fettling here and there, they were fine. Now, I also want to quickly talk about these seat solenoid motors, because they're probably not the greatest solution, and probably the part of the reason why my mate Kevin decided to ditch these is that the system of these isn't perfect. The slow opening actuator style motors are much better, but the problem is you have to remove the springs from your points or your turnouts if you're American. So these are much simpler. They're also quite easy to install as well, but they do require a capacitor discharge unit, which obviously you would have seen me fit. The problem is that once these are fired and those capacitors are discharged, they take a couple of seconds to recharge. Otherwise, when you go to throw your second set of points, it won't always throw properly. You've got to have that space. Now that, for this, is not that much of a concern. There aren't that many points on here, but if you've certainly got a complex layout with multiple pieces of points and you're powering from the same output, unless you have multiple CDUs for a small section of points, which will get quite expensive, you're much better off using slow openers because they don't require that capacitor discharge unit. Having said that, these are quite neat. Now that I've got them working, I am
so happy that this has turned out really well. I was so scared at this point because the electricity and soldering work like this, I've done very little of it. I've done a couple of little loco repairs here and there where I've used a soldering iron, or the little bit where I was sorting power out. Of course, I've changed my mind on that now. But to do all of that work and to have it all work properly, it's given me so much more confidence. Like, yes, I can do electrical stuff now. I can do more complicated things in the future. So on a future layout where I decide to add lighting, or more complex things, or use electrofrog points, for example, providing I follow those explicit instructions of what goes where, I know I am more than capable of making an electrical circuit work on a model railway, which is absolutely fantastic for me, because that gives me such a buzz. I must say, it makes me feel so happy to be able to do that. Another part of the change as well is that I've switched to a Gauge Master controller. Now, I hadn't initially planned on doing this because I wanted to do that train set thing, but the problem is the controller I had was very old. My locos that we are using are also a little bit older, and the problem is that the Hornby train set controllers only have a maximum output of about half an amp. So there's a half amp resistor in there, and if that trips because it's drawing too much current, it then cuts out. That cutout is so fragile and sensitive, and because the controllers are so old, once it goes, it gets weaker and it doesn't work as well. And they're not the easiest thing to fix, and they're not cheap to fix either. So it was made much more sense for me to switch to a Gauge Master, which is a brilliant upgrade, I think, for anyone, because I've tried it. I've set up my big stuff, so I put a bit of track out of the room on the floor, running my big trains on it, and fantastic. And also as well, I do need to film a little bit showing that, because an upcoming maintenance video I've got may be out before this, may not. I'm not too sure how the schedule's going to go, but the controller that was tripping, again, I got rid of, and I think that switching to the Gauge Master controller has fixed the cutout problems I was having with it. So fingers crossed. I do need to double check that, test that to finish filming that. So with a bit of luck, that should be done. So what's next? Well, my switchboard is still in pieces, so I should probably deal with that and the rat's nest of wiring. Let's get it neatened up, make it look really nice and presentable, and actually get my control panel finished properly and looking nice and smart. Let's get to it.
So after that confusion, as you can see, my wires were cut to odd lengths. So I'm going to trim these down one at a time to match the shortest in the run. This is just a case of cutting off the excess length and stripping back to expose the wires and fitting them back to the terminal block. This is going to make everything look so much neater. Once all the wires are trimmed, I'll use some electrical tape to bundle the wires together to smarten things up even further. I'm also going to keep some of the larger offcuts to be used for other types of jobs or any other electronic repairs I may need to undertake in the future. Next, I also tidy up my feed wires from the controller to the track. As I'm using Hornby Power Track sections, I have a set of GaugeMaster GM12 connecting leads which have pins on one end which fit into the track clip. However, as I am using these connector plugs, I slot them into a pair of these instead. I make sure that the screw is tight as the pins are more resistant to being clamped in place. Again, these wires are separate, so I periodically wrap tape around them to keep them together, also further securing the wiring under the baseboard. I also threaded the power and auxiliary feeds through the hole at the front of the baseboard, which makes connecting and disconnecting the controller much easier, just as with the switch panel. With all of that finished, it's time to glue the sides and base of the panel together. I'm just using super glue here, nothing too fancy, and I'm not worrying too much about neatness. And that is job done, and I am rather pleased with how that has turned out. But to finish off, I decided to do a quick bonus task, which was to add some sound deadening to the underside of the baseboard. This foam is actually from the cutouts of train sporter boxes. As I have quite a lot of old and unboxed rolling stock, I needed a way to store them safely, so they don't get damaged. I bought a few train sporter boxes for that purpose. When they arrived, the foam is all there, but the slots are pre-cut, ready for removal. I don't know how effective this will be, but saving something that costs nothing from going into landfill is a win from me. This is just being stuck down with PVA glue and held in place until tacky enough to hold itself in position. I could and probably should have masked off the point motors, but I managed to avoid any overspill that could have damaged them. Well, it's a couple of weeks since I finished the job, and I haven't done much more, but myself and the little one have had plenty of running sessions, which means we've really been able to put the foam to the test. And I'm happy to inform you that it has made a difference. Not a huge one, but it's definitely a few decibel quieter, enough for me to notice anyway. The points and switches are all working well. I did have one motor which struggled momentarily, but I just cleaned the whole of any debris that was in there, and it is no longer an issue. It's approaching summer as I film this, and with some hatch projects looming, i.e. a new kitchen, I need to get cracking on the scenics if I want to get these finished before then, so I can be all hands on deck. But as long as I get the big stuff done, the finer details can wait. So all that's left for me to say is thank you for watching. If you've been enjoying this build series, please consider liking the video or even subscribing to the channel. I do appreciate it, I genuinely do. I've also been posting running sessions, exhibition visits, and even some maintenance videos that I try to keep my 18 fleet of locos running. So please check those out as well. If you are a fellow newcomer to the hobby, I hope I've inspired you to have a go. And if you're an experienced modeller, I hope you've had a good laugh at my expense. Bye for now, thanks for watching.